You are either here or you are outside. So please let your mind be here. Otherwise, I myself will start asking to go out. So the main text for the course is Taylor. Introduction to Management Science. So when you lay your hands on that text, you should be able to follow each of the topics, one after the other. Starting from today, we are going to do an introduction to management science, what management science is, what the key characteristics are, the set of modeling techniques employed in management science. We'll do some small illustration with break-even analysis. Then next week, we will start linear programming, which is basically a modeling approach where you combine inputs to produce a desirable output. And there are three approaches you can employ. You can employ mathematical modeling. You can employ graphical approach. You can also use computer-aided software approach. We'll go through these approaches in the course of the program. Then we'll look at sensitivity analysis as it relates to linear programming. Another programming-based model is integer programming, where the decision variable is either a positive or negative whole number. You can no longer use a linear programming model. So we call it integer programming. After that, we move to transportation, transshipment, and assignment models. In these models, for instance, in the transportation model, you are moving goods from one point to several destinations. Which is the shortest route to each destination? So we do the calculation to determine which route you should follow so that you will minimize cost. Then we have network flow models, which basically similar to the transportation models. But what they do is that if you want to connect so many points, so for instance, there's water problem in Tamil, you want to lay pipes to connect households in various communities. Which route should you follow so that you will use the fewest number of pipes whilst getting all households connected? So the network flow models would help you to do that. You are transporting gas from Nigeria to Ghana. What will be the size of the pipe? How long should the pipe be in order for gas to flow through it efficiently from Nigeria to Ghana at the what? Lowest cost. So that relates to a network flow problem. So look at that. Generally, we are usually able to stop here. We are not able to cover project management, multi-criteria decision making, decision analysis, and then simulation-based models. So this is by way of outline what this course will entail. And because of the nature of the course, we try to be as practical as possible. And that's why I indicated that you have to download some software. so that we can follow what we do in class. If you don't start the class with the computer, along the way you get frustrated. And frustration will give way to fear. And fear will give way to panic. And I don't want that to happen. So that's why I want us to move together from the start. Otherwise, by the time we get to the third lecture, you are lost. And we are struggling to find you. Okay? So as much as possible, try and bring a computer to class or pair with somebody who has computer so that you can follow what we do. All right. So that brings us to the course itself. So this is the text we are using, Taylor. Bernard Taylor. So you can look for it. Everything is Tito. All right. Now, when we talk about management science, we look at it in terms of how we can employ mathematics, statistics, computer science to analyze data so that we can produce outputs that can inform decision making. So we say that management science is simply the application of the scientific method. If you remember with this scientific method, the application of the scientific method to what? Managerial decision making. So that is what it is about. And there are about 6 characteristics of management science. The first characteristic of management science is that it focuses on managerial decision making. How do you make decisions based on fact as a manager? And that is one of the characteristics. The second characteristic of management science is that it uses the scientific approach or scientific method. This is to ensure that decision making is not based on guesswork. It's not based on experience. It's not based on intuition. But it is based on information deduced from what? The data. Using scientific analytical tools. The third characteristic of management science is that it uses a system approach. So you look at the organization as a system. Try to map inputs to output and see how you can connect them to inform decision making. The fourth element or characteristic of management science is that it is multidisciplinary. I've told you that we employ mathematics, statistics, computer science to make decisions. The fifth is that management science makes use of formal mathematical models. So, in management science, you must mathematically state the problem. It's not just going to be a brainstorming session where you say, oh, if this is so, then we have to go this way. No. State the model mathematically. In other words, scientifically. And once you state the model, you can then make use of computers. So that's the last characteristic. There is an extensive use of computers to solve management science problems. And the reason is that some of the problems are so complex that if you want to use your intellect to solve it, it will take you years. And after several years, you may still come out with the wrong answer. But if we employ computer-aided software, we can be faster and what? More accurate in our analysis. So that is why, apart from some few problems, break-even analysis, in the case where we also have just one decision variable, that one we can use human effort calculation. But when you have more than 3 decision variables, if I give it to you, maybe I'll give you one to go and try. It will take you maybe 5 years to come back with the answer. And the answer may even be wrong. So, when we have several decision variables, we rely on computer to help us to solve it. And the computer software we are using, they are not any complicated software. Excel, which is an everyday software that is available on every computer. So how do we make use of spreadsheet like Excel to do these complex computations? What are the steps involved in the management science process? In the management science process, the first stage is to observe. You can observe using instruments, electronic instruments, like drones, satellite, and other scientific equipment, or you can observe by your human senses. So through this observation, you identify a problem. You are observing in order to what? Identify a problem. So first stage is observation. Second stage is what? Problem definition after your observation. Then when you have defined the problem, you now have to state the problem mathematically. And that gives the test, which is what? Model construction. So you build the model. It may not be a very complex mathematical model. It may just be 2 plus 3. But it's still a model. Okay. So it need not be any complex model. When you have developed the model, then you solve it. So that the fourth stage is solution, model solution. The other time I said that the model solution is the easiest among the steps. Because at least there are 3 approaches. can use mathematical approach, you can use graphical approach, you can use computer software aided approach. So if you cannot do the mathematical one, do what? Graph. If you can't do graph, do what? Computer aided solution. Okay. Then lastly, implementation. When you have solved the problem, you will give advice to the entrepreneur based on the solution. So based on the solution, you are telling the entrepreneur that do so and so and so in order to maximize profit. So that's the implementation piece. So, but it's a loop. Because once you implement, new problems will arise, which will feed back to model, new solution, then implementation again, and it continues. So the core of the management science techniques fall within stages 3 and 4. Model construction. How do you set up the model? Model solution. How do you resolve the model? And I told you that there are 3 main solutions: mathematical, graphical, or what? Computer. Let's look at this very simple example. So what you have on this slide is the observation. The entrepreneur has observed that within his space, he is into the sales of steel. So what he intends to do is to produce a steel product. He has further observed that it will cost $5 to produce one steel product. So this is the cost. Cost is what? $5. He has further observed that if he produces the item at $5, he will sell one product at what? $20. But he has further observed that he needs 4 pounds of steel to produce one product. And again, he has further gone to his warehouse and he has checked that he has only 1,000 pounds of steel available. So this one is 1,000 pounds. Well, the place that looks covered is 1,000 pounds. So in other words, the total value of raw material available is what? 1,000 pounds. Whatever he's producing is limited to what? 1,000 pounds. He cannot produce 2,000 pounds. 100. Sorry, 100 pounds. So what is his problem? So this is the observation. Now the problem. So his problem is how many units of the steel product he should produce in order to maximize profit. Given that he has only what? 100 pounds of steel available. So that's his problem. So we said the first stage is what? Observation. Second stage is what? Problem definition. So he has defined problem. Now, these two steps may not look mathematical, but if you don't identify the problem well, the remaining three steps, you'll be lost. So for me, these are the critical areas: the observation and what? The problem definition. Now, so the number of units of steel he wants to produce is the problem. He doesn't know it. So we represent it by what? X. So X is simply the number of units to produce. That is the unknown. We don't know it. But we know the cost. The cost is what? $5. Then his price is how much? So we know the price is what? $20. We know that it will take what? 4 pounds to produce what? 1 unit. We also know that he has only what? 100 pounds of raw material available to him. So his problem is to determine the number of units of steel to produce to make what? Maximum profit. So then we have to move to the third stage. We are finished with stage 1 and stage 2, not so. Now, what he now needs to do is to move to stage 3, which is modern construction. Modern construction. In constructing the model, we must know a number of elements. X, which is the number of units to produce, is called the decision variable. Decision variable. Then we have the objective function. What do you think is the objective of this entrepreneur? What is the objective? Maximize profit. So we call that the what? The objective function. So the objective function is your profit, which we usually represent by C. And profit is equal to what? Total revenue minus what? Okay. So from here, C, using our notation, what will be total revenue? What's total revenue from this? What's total revenue? Quantity times price. Quantity is what? Is what? It's X. We don't know. And price is how much? So it will be what? 21 X. What is our total cost? By what? $5. We are talking about total cost, not unit cost. It will be 5 times what? The total number you want to produce, X, which we don't know. So it will be what? 5x. So this is what we call his objective function. Objective. Now, if you look at the center, he knows that he's only limited to 100 units of steel, but he needs 4 pounds of steel to produce 1 watt. So he has a problem. So he's maximizing this problem. So when we are writing this problem, we say maximize. Maximize this. Subject to a constraint. The constraint is that you have only 100 pounds. But 4 pounds will produce 1. So 4 of 1, x, should not exceed 1. 100. So this is called your constraint. So this is what we call the model, the formal mathematical statement of the model. Simple. So you were looking at it to be some complex kind of, but this is just a simple statement. Remember that we are interested in finding what? X. From here we can find X. So X, we make X the subject here. So to be what? X is equal to what? Over what? Which is what? So we are saying that in order to maximize profits, the entrepreneur should produce 25 units of steel. 25 units of steel. This is the solution to the problem. The problem determine how many units to produce in order to maximize profit, subject to the constraint. And how much profit will be made? We now come and since we know X, we come and put the 25 here and what? And here. So total the Z, which is total profit, will be what? 20 by what? 25 minus what? 5 by what? 25, which will give us 5. In dollar terms, what? 6.7. So that's the solution. The solution gives us 25 units of steel, which will give us what? A profit of 666.7. Yes.
The 20 divided by 25. How will you multiply the theta and the X?
But the X is 25.
Yes. So
That's what.
when you get into the equation,
Yes.
the equation is total profit is equal to 20x minus 5x.
20, but X is here.
Yes. So I'm only saying when we say 20x, what the X is attached to the 20, are we not multiplying it?
But that is due. From that.
So what I want is that 20 by 25 is how much?
We are on this now. So that's how we formally resolve the problem. So what don't you understand? So do 20 times 25. Then what? And you get what? Huh? You got what? Oh, sorry. You added. I use another. You added. So this is the right answer. Yes. So what you need to do is now to advise that the implementation. So the implementation is that the entrepreneur to produce 25 units of the product, and the profit they will make is 375. Now, management science has several names. Why? Because it employs at least 3 disciplines in order to do its analysis. Because we are living in the era of big data, and in the era of big data, data comes in different volumes and in different speeds and different forms. The data can come in the form of videos, can come in the form of text, it can come in the form of what? OT. So how do you employ all these data to perform your analysis? So that's what we call big data. Now, because of the huge volumes of data we have at hand, we would need a lot of computer engineering to handle such huge volumes of data. And that's where business analytics comes from. There are 3 main levels of business analytics. First, we have what we call descriptive analytics. What descriptive analytics does is simply to draw profiles of our business from the data. So we could be using descriptive statistics like mean. So if they want average sales per day, standard deviation, variance, or median for your descriptive analysis. So here you are just describing what it is. Then you move to predictive analytics, where the management scientist is interested in projecting into the future what the current values will be in the future. So we can project future sales, future raw material availability, and so on. That is within the realms of predictive analysis. So we have forecasting model that you can use to forecast into the near and then the far future. Then lastly, we have prescriptive analytics. What prescriptive analytics does is to tell us what we should do under any given situation. What should the manager do under a given circumstance? That's prescriptive analytics. So what we just did is prescriptive analytics. Here, the management scientist acts like a medical doctor, prescribing drugs to the patient. So we are prescribing to the entrepreneur that go and produce 25 minutes if you want to make maximum profit of $375. If you go and you produce less than 25 minutes, you cannot get this far. If you produce more than that, you cannot get it. So the only quantity that can maximize profit is 25. So that's prescription. It's either that or not. Now, in the world of management science, the management scientists must develop some critical analytical skills. The critical analytical skills are required for success in the 21st century workplace. The first is critical thinking. Critical thinking is on the decline. Why? Because right now people want to lie down, even on your bedside, and then when you press this, something will come and start massaging you. Or you want a TV to be attached to your, so you lie down and then you are watching. So right now people don't like sweating. Even those in the village, they don't like to sweat again. So critical thinking is on the decline. If I just give you an assignment, the first thing is for you to go and use AI. So the mind has become that. Because if you don't give it any challenge, it will die down. Okay. So critical thinking is on the decline, but that is one of the key qualities that we need to succeed in our careers in the 21st century. Second is collaboration. Right now, the world thrives on collaboration. You cannot sit in your corner and make this. You must develop a very wide network of useful individuals, not a network of foolish people around you. If within your network, those around you are foolish, your decisions will also be foolish. That's why we say that show me your friend, and I will show you what. If you surround yourself with people that are connected, that they will lead you to places that on your own you will not have gone. So that's how it works. You must have a strong network. So you have to team up together, and then you can work together. Then ICT skills. In this 21st century, you cannot say that I'm born before computer. No. Whether born before or born after. You have come to meet the computer, or the computer has come to meet you. Either way, there's a meeting. So you cannot escape it. So just have some basic data, basic ICT literacy. And now there are a lot of free courses online, YouTube videos, that you can learn some of the things on your own without a formal classroom engagement. So please learn how to use some basic ICT tools. And in this course, we'll be using spreadsheets. Lastly, you need data literacy. We say that data is the new currency. When you have the right data, you can sell it. You can produce a lot of knowledge from the data and make money from it. Managerial decision making should be based on core data. from which data we have deduced patterns, trends, and causal relations to inform decision making. So a lot of you, even your project work, you have no idea where the data is. But I'm telling you, we have huge volumes of data out there for free, which you can use for your work. But because you don't know, you waste your time and develop questionnaire, chasing people to answer, and they are not interested. Because they are tired of answering questions that yield nothing in return. So you must understand where the data you need is, how to access the data, how to prepare the data, how to analyze the data, how to communicate the results of the data, and how to implement it. The first technique we are going to discuss is break-even analysis. What is break-even? Is what? So break-even, at break-even, profit is equal to 0. Okay. So the point where profit is equal to 0 is one we call the break-even point. That break-even point has a volume that we must produce. So the volume that the entrepreneur must produce in order to make profit is the break-even point. And that is what we want to establish. That point where total revenue and total cost curves meet. That's what we call a break-even point. So this will be the volume. So we are just going to do some simple illustrations. In break-even analysis, you need to understand some key variables. Number one is fixed cost. Say fixed cost because it does not change with what? The volume produced. The cost of this generator is fixed, regardless of how many offices are using it, how long we use it, the cost is what? We've already bought it. It's incurred. If we decide even not to use it, we have incurred the cost of the installation. Then you must understand variable cost, which varies with what? The volume produced. So the fuel that is powering the generator is a variable cost. If you want to use it for 1 hour, there's a quantity of fuel you put there. You want to use it for the whole day, there's a quantity of fuel you use. So that one varies with what? Output or production. Then you need to know your volume, which is the number of minutes produced. Then you need your total variable cost. And lastly, you need to know your price or your revenue, your unit revenue. So these are the components of what? The break-even analysis that we are discussing. So that in break-even analysis, we said that profit is set to what? 0. So you have your profit, which is your total revenue minus what? Total cost. But here we are interested in the volume, which is the. So if we make B the subject here, we get the break-even point. So therefore, the break-even point, if we make it being the subject here, will be equal to what? It will be equal to our fixed cost divided by our price minus what? The variable cost. So this formula is very simple but important. Break-even point is simply fixed cost divided by price minus variable. That's your break-even. So let's look at an example. You have a clothing company that wants to manufacture jeans. And this is what they have observed. They have observed that the fixed cost CF is what? $10,000. They have also observed the variable cost to be what? $8. And then the price is what? So their problem is what? Find B. What volume should be produced in order to break it? So that's this formula that we are required to use. So you just plug in the values. So that B is simply equal to what? 10,000 divided by what? 23 minus what? So this one gives us the 666. So the volume to produce in order to break it is 666%. Okay. So this, what we have just done, we can depict it graphically. We can also use computer-aided analysis to solve. And that's what I'll show you next. So, for instance, if you look at this, let's shift. So this is the graphical illustration. Remember that our fixed cost is what? 10,000, not so. So that's this line. So the vertical axis is in thousands. So 10,000. So that's why it's fixed. Then you add the variable cost to the fixed cost. So the total variable cost to the fixed cost. That will give you the total cost line. So it picks out from the fixed cost line. So this is that one. Total revenue starts from 0. If you produce nothing, you get nothing. So it's from what? So it then goes for this the second line on top is the total revenue line. Where the total cost and the total revenue curves meet, that's the break-even point. At the break-even point, total cost is equal to total revenue, making profit zero. So when you trace the break-even point to the horizontal axis, you get the break-even point. So here down to the break-even point. That's the entrepreneur is supposed to produce in order to make profit. Now, when you now get this curve, you can do what we call sensitivity analysis. And with sensitivity analysis, we want to know how the model performs when there are changes in key parameters of the model. Here, the parameters of the model are fixed cost, variable cost, and what? The price. If the price should increase from 23 to 25, will the break-even point shift to the left or to the right? If price increases from 23 to 25, will break-even point shift to the left of the whole one or the right of the whole? Why will it shift to the left? One price, what will increase? So your total revenue will increase. Golden costs. So it's easier for you to break it. So it should be on your what? Left. But it's now easy for you to break it. That's when entrepreneurs will be smiling. Well, the price has increased. Like we've been talking about the KK politics. The price of maize has declined. So the KK sellers holding the price fix and the quantity fix, we should be smiling to the bank. So the break-even point is now here. You don't need to produce 666. Produce less and you still break even. By the time you produce 666, you are already making profit. Now, what happens if, for instance, variable cost increase? Will the break-even point shift to the left or to the right? Holding other factors constant. The variable cost has increased. To what? To the right, why? Yeah, you have to produce more. It will cost you more to produce any unit if you want to produce. So that will shift the total cost, holding the revenue cost constant. So whether fixed cost or variable cost, you'll find that your new break-even point will be your life. So as an entrepreneur, you will be able to get the picture clear. How your break-even point is sensitive to one, your price, two, your what, your cost. Now let's look at the Excel solution. I sent to you exhibit 1.2. So if you open exhibit 1.2 on your computer, you will have this interface. But this is just a raw Excel input. So this exhibit 1.1, 1.2 is also there. with 1.1, we are just trying to use Excel spreadsheet alone to do the analysis. So I just have my fixed cost 10,000, variable cost is price what? Then I want the answer to be here. What I simply need to do is to use this formula, the cell addresses. So look at this way. In Excel, all the cells have their addresses. What is the cell number for the place where 10,000 is? D1. D, so it's in column D. And what? Row 1. Row 4. So it's called what? T4. So that's why you have T4 as a new vector. Then, price is in which cell? D1. D base. What about your variable cost? D1. Okay, so if you just type equal to D4 divided by D8 minus D6, it will give you the answer. Okay, but if you don't even want to type, you just need to put the cursor on those ones, and then it will also give you the same answer. So I can just type it afresh. So fixed cost, I'll just type fixed cost. So I'm using my own cells. So this was 10,000, not full. I'll type my 10,000. Then I know my what? Variable cost is what? H. Then I know my price or unit revenue is what? 23. So my break-even volume. So I want the answer to be where the cursor is. So what do? I just put equal sign. Then my fixed cost is in which cell? D2. So if I don't want to even write, I then move my cursor and click on it to show D2. Then divided by, that's the formula, not to the price, which is what? 23 is in which cell? So I click on P4. I just click on the 23. It will pick it. Then I have to use brackets. Minus what? So I click on it also and I close my bracket. So I just need to enter. Then it gives me my answer. So that way, I just use Excel spreadsheet to do the calculation. But we have furthermore produce spreadsheets that can help you to get the graphs from the cells. So let me close this one. I don't need Okay. So if you open exhibit 1.2, you have this interface on your computer. Now, the formulas have already been put there. So this one, the shaded area, I entered the value there. So you enter your 10,000 in the fixed cost column, your 8 in the variable cost, and then your 23 in the revenue. Then it will give you the answer, which is here. 666.67. Then it will give you the graph as well. This is the graph. Which we just discussed. Okay, so this is the graph that comes from it. So if you go and change the elements, you can then now do sensitivity analysis. So for instance, I may want to see what will happen if I change the price. It's editable. To say 25. You can just change it to see what will happen. When I change the price to 25, the break-even point comes to 588.24 instead of 666.7, which means that my break-even point will now shift to the left. If I reduce the price to 15, let's see what will happen. The break-even point will shift further to the right to 1,400. So you can play with it. And it should also change the graph as well for you. So this is just a simple Excel spreadsheet. But I ask you to also download Excel QM. That one, if you don't install it, you cannot have exhibit 1.3 opening well. Because that one uses the XLQM software So on my desktop, you would have seen, you can see this icon here. That's the QM. So that's what happened. All the management science tools are available there. You can see them here. If you want to do break-even analysis, that's the second one. So you choose this one. If you want to do decision analysis, forecasting, code programming, integer programming, inventory, Markov analysis, name it. All the interfaces are there. And they are pre-formatted. Among the softwares, this usually is the simplest. Because it just requires entering the parameters in the model and then output will be. So if you open it, you can go to where you save the 1.3. That's the exhibit 1.3. So that I want to now want to access this. Right, it's not allowed me to open the So once you when you open the window of the QM, you now go to open, then look for the exhibits. And this is the exhibit 1.3, which I shared with you. So you can then click on it and then you open. So it will bring you to this interface. Now, in this interface,
So this is an accessory. That association is secure. Okay.
so
Yes,
fixed cost is what? 10,000. You see that in the column.
whatever you say.
Variable cost is what? 8. And then you have your what? Your price, which is the revenue per unit as what? 23. So all the elements have been entered. All you need to do is to go and click on top there, you see a green arrow with what? Solve. So you just click on it and it will solve it. So it solved for us the volume and then the total profit. This is the profit. And this is the volume. Now, it produces a number of outputs. You see that the solution button is there at the top here. I can view the graph by clicking on the solution button. Graph option is there. I go back, click on it. This is the results that we got initially. So I can ask it to redraw the graph, whatever, change the color, make the default black, whatever. So in this particular interface, even if you are just given the questions, you can just come to the interface here. You just open the QM as to this more or less a blank page. So under model 3, I choose cost volume. It asks me about the number of cost items. Of course, we have 2 cost items, fixed and variable cost. Then the number of options and so on and so on. From here, I can then do my analysis without much of a problem because you can use this arrow. So I'm trying to see, you can use this arrow to change the number of items. So in case you have more than 2 course items, you can change it. The same with the output option. You can change it. So this particular interface contains analytical techniques for all the problems that we are going to be confronted with. This game theory, if you are dealing with a 2x2 integer programming, I'll show you how to enter the values in each of these equations. And just by clicking solve, you get the solution to all the problems that you are confronted with. So, by and large, as I indicated, the solution part is the easiest. The difficult part is building the model and ensuring that all the model components are intact. Next week, we will try to start by doing some basic Excel spreadsheet analysis, even though that one is not really part of the course outline. But just for you to be able to follow what we'll be doing subsequently. All right. So lastly, these are the combination of techniques that are used for management science. We group them into linear mathematical programming. So they entail linear programming, which we start next week. Graphical analysis, sensitivity analysis, transportation and transshipment problems, integer programming, and goal programming. So they are one group, we call them the linear programming techniques. Our course will be largely based on this. Then we'll come and pick from one of the network techniques. We may not get time to do the probabilistic techniques. Probabilistic techniques make use of statistics to do the analysis. We call them probabilistic techniques because there is uncertainty regarding the parameters. So you are dealing with uncertain outcomes. In statistical analysis, we have deterministic outcomes and what? Uncertain outcomes. So probabilistic techniques will help you when you are dealing with uncertain outcomes. Then we have network techniques. We will try to look at network flow diagrams. We have analytical hierarchical process models, nonlinear programming models, simulation and inventory-based models. Then we also have other models which we will not be able to treat, but of course they are still treated within the text. In case your curiosity is aroused, you can dig deeper into those kinds of models so that you can have a deeper understanding. So from what we did today, when you go, you can try your hands on this question. You can try to get your hands dirty by going through these questions. We have solved them or similar ones in today's lectures. So this is to test your understanding, whether you were here in body or you were here in body, spirit, and soul. All right, so thank you. Any questions? No question.
So my question is a bit diverse. How they diverse from the topic of the day?
Why?
How they have to find out. It has been happening in recent times that you find yourself in a lecture or wherever you are, you realize that lecturing or teachers or presentation often use the dollar sign instead of the city sign. I don't know whether it is something that is programmable or because it's what we talk about with the adult Ghana that if you each one to do everyone.
Ghana is not a village, and we are not training you for Ghana. We are training you for the world. If I use dollar, if you want, you can change it to your nose. When you are writing dollar, you can write it. But that's the reason we are training global scholars, no local champions. Yeah, it's different from scholarship. Scholarship is a global one. You can see that the textbook we are using is not made in Ghana. You understand? We are not using made in Ghana textbook. This is a global subject. Your colleagues in Harvard, that's the same textbook they are using. So if I now come and I am using Ghana, you understand that? I'll be training you for Ghana, but we are training you for the world. So I understand, I think you are a nationalist. I understand where you are coming. Thank you. All right, see you next.
Yes, sir. I noticed that the keyword, the sales windows 5.2. Yeah, I think my boss asked for the keyword. The section of the keyword.
No.